And we're live. Hello, everybody. Welcome to another meetup. We're fashionably late today. We had some technical difficulties, but we're here now and we're going to show some cool stuff. Before we go to our speaker, let's go to our panelist for today. Stefan, how are you doing today?
Very good, very good. A bit unusual time for meetup, but
yeah, well, sometimes a different thing is good, right? Sander, how are you doing today?
I'm doing just fine. I'm missing stand-up, so I'm missing our meeting to be in this meet. I think it's a fair trade-off.
Right? This is a cool topic, so why not?
Yeah.
So, and then we have Wassim. Hello, Wassim. How are you doing today?
Hey, folks. I'm doing well. I'm sorry about the time. I know it's my fault.
Wow. Sorry, let's go to your slides then, and we'll share your screen again.
Sure.
And the floor is yours.
Okay. Yeah. All right. Let's dive in. So, hello, folks, and thank you for joining us today for this talk about what I call the new era of static web apps. All right. So, before we talk about static web apps, what they are and how or why are they cool or interesting, let's go back in time and talk about the history of the web, like where we come from. So for that, let's start with the Web 1. I don't know if some of you recall the era of CGI, Common Gateway Interface, and the web of documents, basically with just like links and really simple forms with basically no CSS at all at that time. So yeah, you had the browser with like some simple static HTML and even no JavaScript back in that time. And on the server side, we used to have CGIs and mostly written in Perl, which might look like this simple script here that get request for a form submission and probably do some processing on the back end. So the HTML page was all like written in a couple of scripts and like bare like strings, I should say. And then sent to the browser, and the browser renders that simple HTML. And then when you had to communicate back with the server, yeah, you would use a form and the action method, the action property attribute, which would go back to another Perl script that would handle your request by like simply getting all the form inputs and do some processing on the back end. Really simple, right? So the architecture was quite straightforward. We had the browser making requests to the server and the CGI doing some processing on the back end, and then sending back the request, the response to the browser. All right, and then came the Web 2.0. Actually, that's where I started web development back in this era with fancy web pages and buttons, glossy buttons, those flashy buttons. And actually, fun fact, that is when I made my first website. So that's the website I created using tables and CSS and like some really simple JavaScript, vanilla JavaScript back in the days. I think it was in 2005 or 6. Yeah, before jQuery. But what's interesting about the Web 2.0 is this the Ajax, the Ajax paradigm, and also the single page applications era. And one of the most famous single page app was Google Maps. Why was it famous? Well, because you actually could interact with the web page without refreshing the whole website, the whole page. So you would, use the embedded map, navigate, click on the map, and then get some live response made by by browser requesting the server using Ajax, without really having to refresh the whole page. That was really revolutionary back then. So the architecture was somehow also, I say, simple, just by introducing this Ajax API, which, by the way, wasn't new back then, because I think it was created in the 19s. While they're using Ajax, you would request the server, like request information from the server, and then you get back that information and update the UI using JavaScript, again, without refreshing the page. The next iteration of the web was the Web 3.0, and that's basically was the era of Semantic Web. So the Semantic Web was it's a terminology that was introduced by Sir Tim Berners-Lee, the father of the web. And back in the days, this idea of the web of data was mainly promoted by the W3C, and basically, yeah, they promoted the common format of the www, and also by encouraging the inclusion of semantic content in web pages. And one of the interesting things here is that also instead of showing data to the users through web pages, then you would also allow machines, to communicate between them by allowing, accessing data from directly from servers. So this is where we had things like resource description framework, or RDF, the RSS as well was really popular thanks to Web 3.0. And now we are in the current time, and I'm here to talk to you about the new era of static web apps. And my name is Wassim. I work at Microsoft as a senior developer advocate, focusing only on JavaScript. And if you have any questions about this talk at the end, feel free to ask them at the end of this talk, or you could reach out to me directly on Twitter. So yeah, the new era of static web apps. So what is a static web app? My definition of static web apps is really simple. Static web apps is a really traditional single-page application that we're all familiar with, just with some slightly superpowers. So a static web app is supposed to be fast to load, fast to render, because it was probably server-side rendered, and also fast to use. We have minimal JavaScript loaded the first page interaction, and optionally it uses some sort of some serverless API. So that's I agree that's maybe a fancy word to just describe some common architecture that we're all used to. And that's why you can use your favorite stack that you're also used to, even HTML static, JavaScript, or simple CSS, but also any popular JavaScript framework that you're using today. That's basically a part of this new paradigm that we call static websites or static web apps. So the model, or the architecture model of a static web app stack is kind of similar to the SPA one, the browser requesting the server using Ajax without refreshing the page. That's easy. But then the static content might come from some sort of CDN or like storage that is, near the user and like fast to load with caching and all the cool stuff that helps the website render fast. And on the back end, you could use any serverless service or API accessing your favorite database and then fetching the data and showing it back to the user. Really nothing fancy here. So at Azure, we took this architecture and we want to help developer take advantage of this and use the new Azure Static Web Apps service to deploy your favorite JavaScript framework stack. So Azure Static Web Apps basically helps developers focus on their business logic, on their apps, by overloading the the build and hosting configuration, all the stuff on the service itself. So it also gives you a couple of features that you can use with your app, like authorizations and authentication, like really embedded into the service. You could optionally, as I said, take advantage of the Azure serverless API using Azure Functions. And what's cool about this, it is directly integrated with GitHub Actions and automatically configures the CI/CD for you. So again, you as a developer should only focus on your application and not the configuration. And you get also, again, some nice features like the possibility to add your custom domain and also get in free SSL, and because HTTPS is important. And also your content is geo-distributed, which is really, really important for having, those sites to load fast. When it comes to authentication, Azure Static Web Apps support a couple of auth providers: Azure, GitHub, Google, Twitter, and Facebook. There are other providers coming. And the Azure Static Web App classic flow, I would say, looks like the following. So you, as a developer, again, would just make changes to your code, commit, push your PR, and then automatically the created GitHub action that was done by Azure Static Web App Service would take care of building your app, testing it if you've configured testing, deploying it onto Azure Static Web Apps, giving you a I would say a domain that you would use to preview your application or your changes, and also all the neat features like authentication and authorizations. And if you're using a serverless API, this also would be deployed to your Azure Functions instance automatically for you. And then you get the URL to your app that you can preview or use it. The Azure Web Apps architecture looks like the following. Okay, I'm going to explain this. So you have the browser that would load your. Let's say you access your website, you get a browser, then you load all the static content from Azure Static Web Apps, and you really don't care where your static assets are hosted. They are geo-distributed and really accessible from the domain. You don't care where which storage or which CDN they're served from. Your API would request the serverless Azure Functions functions project as usual. There's nothing new here. You would still use the Azure services on the backend side, accessing database, accessing logs, I don't know, like if you're using some IoT fancy services, this still would work. Nothing changed there. And when it comes to the authentication service, this would, provide you with the one that I mentioned: GitHub, Twitter, Google, Facebook, and Active Directory in a really complete, transparent manner. As a developer on your local machine, we also provide the Azure portal that allows you to, you would create your instance there and have the Azure Static Web Apps connected to your GitHub account in order to set up and create the GitHub action for you. You could also do this from your VS Code using the official VS Code extension, or you could use the Azure CLI to do the same. We also have, and we will have, a static web apps CLI, which would serve as a local emulator for you. Like as a developer, you would try your app locally before deploying it. So again, the VS Code extensions is really cool. If you're a VS Code person, we have that option for you. Of course, the portal, which you probably have used that before in the preview. We've upgraded, by the way, the UI on the portal. Now we provide you with some presets when you create your Azure Static Web Apps instance. So we provide you with, the common JavaScript frameworks. So just to speed up the creation process. And by the creation process, I mean fill in the form information there on the UI. And the Azure Static Web Apps CLI comes also with some features like emulating the authentication and authorizations, and also some other features like building your app locally before serving it locally again, and also taking care of routes configurations and everything that basically that the Azure Static Web Apps cloud instance would provide. So this CLI is security still under implementation, I would say. But you're welcome to try it out and give us your feedback. All right, I provided some demos. So I have this app, which is basically so it's an Angular app that shows you your GitHub stats when you're logged in. I'm going to switch my screen and show you the. Okay. Where is it?
Always nice when you're doing a demo.
Yeah.
Right.
Oh, I think that's because I'm full screen. That's why.
Yeah, probably.
All right, now I'm not full screen. Okay.
Yeah, there it is.
I wasn't able actually to drag my shell in there. So here I'm in the first demo, which is this GitHub badge app. So this demo illustrates the use of authentication. So to try it locally, I would call this SWA CLI with the start command and give it the folder location where my list content is provided there. So I will just let it start it, and this would start a couple of servers locally, grab all the configuration that's needed for my project. And if you have a GitHub action created in your project, the CLI would use it and use the information you have there to build or serve locally your app. So now my app is served locally here. Have some bad caching. I was playing with it earlier, that's why. So here, when I click login here, I would use the default Static Web Apps built-in authentication provider, like GitHub provider. We'd go through the the classic GitHub auth demo. Okay. Live debugging.
And that's what we're all here for, right? Just code together and fixing the bugs.
Never build your app before. Okay, let me start again. Right. Going back. So going back in time. So if you log in here, if you do this on production, you would go through the actual authentication flow with Azure Static Web Apps. Go in through GitHub, then getting the token back and allowing the developer to do whatever they want. So locally, because we don't want to emulate the actual authentication process, obviously, so we have like a different flow. We actually show you this UI where you can manually configure the authentication information that you would use locally, which would also serve you while testing, maybe. So here, it automatically detects that I'm using GitHub as a auth provider. I have filled my username, some random user ID, and I have my default roles. If you're like, if you're using ACLs, which I'm not using here, so I click login there, and then goes back to my application, gets my token, and then show me a couple of stats. Clean and easy. I have actually here an Easter egg. So if you're using this app on production and you hit Shift, you see the login button turns orange, then you refresh your page. And now if you try to log in, you would use Auth0 as your authentication provider. Log in with GitHub, and then obviously you get back and have the same result. So, and the app is open source. I mean, the code is open source. You can check it out. It's quite like really easy to implement. Have like two Angular services, one for built-in authentication and one for Auth0. All right, so that was the first demo. The next demo is another app that I built a couple of months ago, which basically generates some funny cat's name. If you have hard time finding a name for your new cat. So this API demonstrates the use of the API backend. And fun fact, the API here, the backend here for this app is written in Rust and compiled to WebAssembly and then deployed on Azure Functions and served with Node.js. But you don't need to care about that. That's just a fun fact, which is not important for this talk. So going back to my shell here, I need to just cancel the first CLI instance. And then, so here, same thing. I need to start my CLI, and I would provide it with the folder to my Angular static content, which is already built in this case, which is here. And because I'm using an API, I also need to provide it with an API that is located in the API folder. So now I start my local experience with the CLI. And then, as you can see here, I have the API being compiled and run by the CLI. Now, if I open my app locally, again, that's because I'm using cache, just hard refresh. So yeah, that's the app running locally. Ask for a cat name. As you can see, I have my app, like, as you can see here, my requests are being fetched locally. So yeah, so that's two demos of static web apps. We have built actually tons of demos with different frameworks like Eleventy, like Scali, like Stencil, Angular, React, Vue, all the common JavaScript framework static content like HTML, CSS, and classic JavaScript as well. Yeah, if you want, you can check them out. I have links at the end of the slides. And I'm currently actually writing a blog post on Dev2 about how to deploy Scali on Azure Static Web Apps. And I might need some approvals from Sander before publishing it. So Sander, I might need your help next week, maybe, if you have time. All right. So yeah, that's
I will make time for you.
Thank you so much. That was all for me. I have here a couple of links if you want to try out the service or report any issues you have on the preview alpha. I mean, excuse me, the preview release. And yeah, thanks to just want to take some time to thank my GitHub sponsor homies. And also, if you want to help me save the planet, you can join Ecology, or if you don't want to join, unsubscribe, you can just donate to my profile. All right. Thank you so much for listening to my talk. That was the new era of static web apps.
Well, thank you for your sharing your content and your knowledge. So I think somebody was very happy with it, because I saw like Venice said this is very good, and this was what he was waiting for, because he's even taking care of 10 cats and he needs to give them a name. So you helped him basically with providing some names for him.
Please, you can try Catsify, and yeah, if you like the name that you get, just you can tweet it out as well.
Yeah, so I saw like the free Azure account. What can people expect from that? Could you explain a bit? Because I think a lot of people looking at this show would like to try it out. You know.
Yeah, sure. I mean, like any cloud provider, we have free quota. Like you can register for free for 1 year, and you can try all the services for free. You also have, I think, $200 to try some of the other services, and even like beyond the 1 year free, like the free year, we also have like services and product that have free quota. Like the Azure Static Web Apps will have free a free plan that you could use, and there are also like Cosmos DB. They have free plan even after the trial period. So yeah, that's that's what is it, like the free Azure content.
Oh, great.
I missed a fact in your sum up of the history of the web. Ajax is actually a Microsoft invention that came with Internet Explorer 3.
Correct. Yes. In the 90s, right? I can't remember the date.
It's I think 94.
Yeah.
I started building my first web apps in 92, I think. And I remember this drama.
In 92, I was like 4.
Yeah, I moved most of my development to the web stack in 92, 93. I think this thing is going to be something, and turns out I was right.
Yeah, I remember the era of ActiveX.
Oh yeah.
Yeah. Anyway, that was the past. Now we're so lucky to witness this new way of building apps. They have different names. Some of them some they call them Jamstacks, other call them static web apps, static websites, whatever they call them. It's a fun period.
Yeah, I don't think the name is that important. Jamstack sums it up pretty well, but static web apps is also a good name for them. We enable Angular to build it with Scully, so.
Yep.
Yeah, you just need to know when to use it, right? That's basically it.
There is like a set of web applications that are never going to be suited for like static deployment, and there is a whole slew that is very suitable, and there are sites that have like partial support.
Yeah, definitely. If you're having building a blogging platform like articles or whatever, those can be converted to static content.
Yeah.
However, like if you're building an e-commerce, you probably would have like a hybrid solution, because otherwise you would be updating your cache frequently if your prices change. You know.
You can do a hybrid solution.
Yeah.
With which is suitable for most things. Like you can generate everything, and then the part where your login data is, so your username will be grayed out on initial render, and it will come in when you're actually authenticated and stuff like that. It needs you need to look a little bit different from static web applications.
I mean, that's why. Yeah, obviously that's why you need a serverless API just for some dynamic content that can be server side rendered.
So one of our viewers had a question, and I hope I pronounced your name correctly. It's Amin. I'm not going to try your last name because that is something I will probably say incorrect. He would like to know what the added value is when you're using like a .NET backend, and how could we handle them? Like, how could we use .NET in the backend and Angular in the front end, as an example, basically? So what would be the added value for? Sorry.
Do you mean in the context of Azure Static Web Apps, or
yeah. No, in context of static web apps.
So I mean, yeah, obviously, if you're familiar with .NET, you could use .NET as a backend, and then it's supported by the service. So we have Python, .NET, and Node.js. There is no particular reason. That's up to you. If you have like experience, like more familiar with .NET, use that as a service, to build your API. The thing is, you just need to use it as an API server, not MVC solution. You would still need some static framework or static content from the front end using Angular or any other framework, and just use .NET as an API that serves JSON responses. Yes. Because you want otherwise you're just like breaking this Jamstack / static web app static sites paradigm, because your content can't be hosted on CDNs and then easily accessed by the users. So if you can server side render .NET content, do that, as we do with Cli for Angular and Node.js. If you can't, I would probably look at different solutions to have like this separate front end from the back end.
So basically what you're saying is like just separate basically like the APIs, go API first approach, and then use one of the decent frameworks for your front end. Sorry, go ahead.
Correct. That's exactly what I said in one of my slides. This new era, and by new I should probably put quotes in there because there is nothing new in there. It's just based on the SPA paradigm, single page application. So if your app is already a single page app, it's already a Jamstack or a static web app or static websites ready application.
Yeah, you probably need to do some things to get it on with the Azure Static Web Apps, but that's it, probably.
Static Web Apps and Azure Static Web Apps doesn't solve any existing issue. It just like helps you deploy your existing static content or static app. The problem here, if your app is built on an MVC model using Java or .NET, this might have some limitations. For instance, if you're serving mobile users as well, if you serve both browser and mobile customers, because on mobile, slow network, all the stuff, so you need to have separate content that load fast on mobile devices. And SPAs is one of the solutions that helps you reach out to those users. Excuse me, Sander, you had
I was thinking, so server-side rendered applications are not a good suitable target for those, for the SVA paradigm. You can, of course, you can use SSR in a Firebase function, or it's not Firebase function on Microsoft, it's called different, an Azure function.
Yeah, you can use dynamic server-side rendered content. That's what I called hybrid solution earlier.
Yeah, then you're going really hybrid. Yeah.
I think, and I might be wrong, but maybe 90% of the use cases would be hybrid, because there is some content that can be server-side rendered and served as a static content directly. and I might be wrong here. But I mean, yeah, hybrid solution works well. You could probably like server-side render maybe 80% of your app, maybe, and just like have a server-side solution with Firebase, with Azure Functions on the backend that's dynamically,
Yeah, it's like you
Right, yeah.
said. If you have like an e-commerce app, probably your shopping chart will not be pre-rendered.
Yeah.
That will be a little bit difficult. And also, the prices might be dynamic, a little bit more dynamic.
Right.
So you can generate like 90% of your site, but you have to take care of the last 10% by having servers boot up.
Yeah, and even if that's a one of the bottlenecks, of server-side renders, I know like some of the e-commerce like platforms, they cache their pages, but then they have to rely on a reverse proxy or like some sort of a front door server to invalidate the cache and everything, which is outside of this talk. So again, yeah, you go ahead with any backend, Python, Java, Node.js, or .NET for your app, as long as this is like already an SPA application that you're working on.
Yeah.
Okay, Paul. Yes, you need Scully, but probably Wassim has a different story.
You saw the question already, right?
I didn't see the question.
So the question is, if I have an existing Angular app and I want to host it on Azure, would I need to have Scully to handle the generated content before deployment?
Definitely.
So yeah, the first answer would be definitely. If you want to have a more like performant app, Angular app, you would use Scully to server-side render your apps and like serve them as static content. However, if you can do that, and that might be an option as well, you could deploy it on app services on like a Docker container, and yeah, serve your app, and maybe have some sort of Angular Universal on the backend, or even Scully maybe for the dynamic option. Otherwise, if you're like using a Node.js or .NET server or whatever, you could still do that. Like there's like app services is the last option for you. Just package everything in a Docker container, Docker file, Docker container, and then like deploy them on Azure. That's an option. But first of all, invest some time looking at Scully, add it to your app. And my blog post is actually about that, how to add Scully in your app. But I mean, there are tons of content on the internet now. I don't know if that answers your question.
Yeah. To be serious, you don't really need Scully to put an Angular app on this thing. You can put it as is, but Scully will help you get better at performance metrics.
Yeah. Okay. So Paul, I hope this wasn't at least an answer or a direction on your question to investigate what you need basically. So I don't see any other questions. Sander or Stefan, do you have any questions still for Wassim? Did you want to know some Azure cool stuff?
Well, maybe very general one, if you could compare cloud providers in terms of static hosting, like if we compare to some AWS solutions, some, I don't know, benefits and good and bad parts for, I don't know, if you can tell something that if we compare some cloud providers.
I'm sorry, that was a question?
Yes. So if I would choose, like, which cloud provider for use, I have static web solution, and should I go to AWS, and maybe you have any like suggestion which way to go in which situation? Why sometimes it's better to use Microsoft Cloud, Azure?
I think maybe I can take this question a bit, because we are working heavily with Amazon, but I've worked in the past with Google and also with Azure, and I think it depends a bit on your organization, because all these things are basically in all the cloud providers. They all have a different name, but they are already there. and it just depends a bit on if you let's say your organization already has like something at Azure or maybe using the Microsoft stack. Probably you will use the Azure stack because the Microsoft stack, because also like billing and that kind of stuff, that's easier for your company, and if you're more like an Amazon fan, then you will go that way. And I don't think there's like a guideline when to choose. It's just based on what you need and where you feel comfortable with or how. If I, for example, look at Microsoft versus Amazon is like a bit technical. You need to be a bit more taggy to understand a couple of things there, which Microsoft is like, at least for me, and that's personal opinion, then is like a little bit easier going on the UI parts. So there's not like a real direction, I think.
Yeah, I mean, your question, Stefan, is also can be compared to should you use Angular, React, Vue, whatever framework. It's really up to you. It's like what's the issue that you're trying to solve with your app. However, and I agree with that, like on the cloud provider parts, there is this this bill in the price, so that's something you probably want to compare. But again, most of their prices are fairly similar.
The pricing is very similar, and comparing prices for cloud providers is like higher math nowadays.
Yep.
You need to go like to a gazillion of pages and fill in like a gazillion of data that you don't know yet, and then you go, that one is cheaper. It really depends on your use case, on how the data is used, is your application gathering more data than it is sending out, or is it sending out more data than it's gathering? Yeah. It is really complex. I've been working with all of the providers, and I would say go to Microsoft. They employ most of my friends. So
yeah, and even if I work for Microsoft, like I won't necessarily advise you to go to Microsoft if you're, for instance, you're like have an account or like you're paying for services at another cloud provider. However, I would advise you to to have probably different.
Take a look. Take a round.
Yeah, take a look, and also, do not deploy your whole infrastructure at one single provider. If that's your business, if you're caring about your business, you probably need to have some backups. Like for instance, doing like hybrid solution, like deploy some bits on that cloud provider, another API on another cloud provider, and so on and so forth. Just in case there is some outage or some issues with one cloud provider, you would probably need to to revert to a different backup. Have some backup solution. That's what I'm trying to say.
Basically what Wassim is saying, build your own Kubernetes cluster and you can host that everywhere.
You don't have to go and like to Kubernetes itself. Just start with Docker. Have your like reproducible Docker environments and have it like deployable into different cloud providers. But again, like check out the pricing and check out the availability. Check out also the regions, because I know like Static Web Apps is deployed in 5 different regions across the globe. I don't know about the other, but I bet they have the same thing. So if you're having your like your business is mostly in the Netherlands, you should probably have like some data center near the Netherlands for like faster page loads and stuff like that.
Luckily, both Microsoft and Google have a data center in the Netherlands.
Yeah,
so
probably, yeah. So again, there are like lots of different criteria that you need to, basically have like a matrix with all the criteria and like make decide. And
if you have a simple application, look at like, I think the Azure SVA thing is really easy to get started with. Google, you end up with Firebase, which is really easy to use. But GitHub Pages may even be a feasible option for a proper static web application. If it's just documentation and there is only little interaction, that might work. It's also Microsoft, so
if it's only, I mean, it's not it's Microsoft, but it's still GitHub. It's a different company. You could still, there is also Netlify, there is Vercel, there is Heroku, there's lots of different options.
Yeah.
Yeah, you have choices. I mean, we are really, I mean, as developers today, we're really spoiled. You know, we can have like many options. Some of them are free, some of them are not. But you know, if that's your business, you can afford paying for that.
If you create like a small Docker compose file, you can basically host at almost all providers. Yeah. I'm using a DigitalOcean thing for like a €10, a $10 a month thing for like an experiment we are running, and that is working out really well. And actually, that will scale up pretty well also when needed. But you need to, and the reason I chose in this case for DigitalOcean is because they have the simplest offering. You go to the site and say, yes, that one, it will cover what I need. And if you want to have like simple Docker hosting, on Azure, I would love to have that, but going to the Azure site and find simple Docker hosting, it takes a day to find it. It's probably cheaper.
Correct. There might be another option, which we usually don't talk about, which is the developer experience. So you as a developer who is in charge of deploying or like maybe sometimes configuring the CI/CD or stuff like that, I would use that also as a criteria to decide. Like for instance, like I know like to me, like Firebase, they have the best experience, like developer experience. If I have to choose, I would probably have that as a requirement, you know. But I know for most businesses, usually it's not the developer who decides which cloud provider. Because it's the company is paying for the fees and everything, so the decision comes from higher.
Yeah. So to wrap up, look at your technical specs, what you need, and then choose just one, or basically two, but just to be sure.
And if you still have questions, just ping me on Twitter. I'll help you out.
Okay. If nobody has questions, our audience doesn't have any questions, then it's a wrap. Wassim, thank you for your time. Really appreciated that you were here.
Thank you for inviting me.
You're always welcome back. And well, until next time, everybody. Bye.
Bye.